Alright, what we have in this video is the last major log problem, which is solving a log equation where you have x in the exponent and there's no logs anywhere, but we're actually going to need logs in order to solve here. Okay, now before I even begin this problem, I'm going to just kind of get familiar with it a little bit. 7 to the first power equals 7, and 7 squared equals 49. So before I even begin, I'm going to realize that my answer is going to have to be between 1 and 2. Right? Because what this question is really asking is 7 to what power is 23? Well, 7 squared is too big. 7 to the first is not big enough. Okay? So in order to solve this problem, what we do is take log of both sides. So I'm going to take log of the left-hand side. And if you take log of the left-hand side of the equation, you have to take log of the right-hand side as well to keep the equation balanced. Okay, now the reason for doing this is because what this allows us to do is this allows us to take the exponent and rewrite this as a coefficient. Okay, so my next line is going to look like x times log of 7 equals log of 23. Okay, so now I'm solving for x. X is down as a coefficient. So right now x is being multiplied by log 7. So if I want to solve for x, I'm going to divide by log 7 to both sides. So therefore, these divide out, and you just get 1x. So you get 1x on the left-hand side. On the right-hand side, you get log 23 divided by log 7. Okay. Alright, now when I took the log up here in the red writing, I took log base 10. Okay, I never wrote the tens because if you just take log, it's assumed to be base 10. And the reason for taking log base 10 is because then now I can go to the calculator. Because the calculator works in log base 10, I can type in log 23, make sure I close the parentheses off, divided by log 7, and this will give me a decimal approximation of the answer. So it looks like x is 1.61, and then continue with those decimals there. So I'll round it to two decimal places. So my final answer is going to look like, there's the exact answer. The rounded answer is x is about 1.61. Okay. And you should be comfortable giving both answers. And this follows my prediction that x should be between 1 and 2. Okay, now let me give you one to try here. Two times 5 to the x power plus 1 equals 9. Okay, take about 30 seconds. Okay, now this example I'm giving you is to highlight the idea that you need to get the part with the x and the exponent by itself before you take log. Okay, so what I'm going to need to do is first subtract 1 to both sides. So I have 2 times 5 to the x power equals 8. Okay, now we have 5 to the x power. Right now it's being doubled. So I'm going to divide both sides by 2. This eliminates these 2's, because 2 divided by 2 is 1. So right now I have 5 to the x power has to equal 4. Okay. Now before I proceed, and kind of get familiar with this, I know that 5 to the first power equals 5. I know that 5 to the 0 power is 1. So therefore my answer for x is going to have to be between 0 and 1. Right? Because this, again, is asking 5 to what power is 4. Okay, now in order to solve this, I'm going to take log of both sides. So take log of the left-hand side equals, and take log of the right-hand side. And again, the reason for this is now I have log properties that allow me to take the exponent and roll it out in front as a coefficient. So what we have is x times log 5 equals log of 4. This is x is being multiplied by log 5. So I'm going to divide both sides by log 5. So therefore, on the left hand side the logs divide each other out. You're left with just 1x equals log 4 divided by log 5. So there should be my exact answer, and if I go to the calculator we can approximate this. Log 4 divided by log 5. And this is supposed to be between 0 and 1 according to my prediction, and this seems to be correct. I got 0.86. So there would be your rounded answer.